Welcome back. All right, so today we're going to start working on Unit 5 Day 4, having to look at a lot of parallel lines. The other days when you saw the saw the lines and you looked at the angles, whether they're alternate, interior, corresponding, the lines weren't parallel. Now these are specific situations and we are still going to have parallel lines. So just go over again what these are. So lines on the same plane. So same surface that never intersect. So they're never going to cross over each other. You will have transversals of the diagrams you're going to see. The symbol for parallel, so if you have two lines, so if this is called A and this is called B. So if these two lines are parallel, you're going to see one of two things. It's either going to be written that A is parallel to B. So that means when you go look at your picture, you're supposed to identify that A and B are parallel. Or if you had a picture with, it wouldn't necessarily say this, but in the picture, let's call this M and N. If the picture is like this and it has arrows, now these arrows are not going to be here on the ends of it. They might also be, but if you see somewhere sitting on the middle of them, and this actually happens this first diagram right here. So if you see these arrows right here sitting somewhere inside the lines, inside the arrows, this automatically means parallel. So this is a parallel symbol. To take into consideration, it has special properties. Now, when you are looking at, you're going to be looking at the same picture as you saw before. You have two lines. This time you're going to be told whatever the names of these lines are, they're parallel, and you're going to have a transversal going through them. Now, when this happens, you still have corresponding angles. You still have alternate interior angles. You still have alternate exterior angles. You still have same side interior and same side exterior. So you still have all those things. However, special things happen. When lines are parallel, the corresponding angles are congruent to each other, so they're all equal. You have alternate interior angles that are going to be congruent or equal to each other. Alternate exterior angles are also going to be equal. So now all of these angles aren't going to be equal to each other, but a situation like this. If this was a 70-degree angle, this was given to you, I might say fill in every other angle measure in here. And you would say, okay, vertical angle is here. And then you can take this and say, because this is a straight angle here, I do 180 minus 70, and I get 110 here. Again, that comes over. You say, well, I got that first block filled in. Now, since the lines are parallel, this block of 4 down here repeats itself. So the same pattern happens. So up here is 70, so up here, same corner, those are corresponding angles, they're the same. And same, you got alternate interior that are the same. So this is 110 also. The patterns are going to be repeating themselves. Alternate exterior are the same, so it's 110. Vertical angles, everything fits together. Parallel lines, you just have that repetition of the same number. So when you look at this, you can see corresponding angles are congruent, alternate interior are congruent, alternate exterior are congruent. Now, it would be fantastic if same side interior, same side exterior follow the same thing, but unfortunately they don't. So when you look at a pair of same side interior, so I'm going to abbreviate same side interior with SSI. When you look at the numbers, you can see these are not the same. They are not equal. But if I do 70 plus 110, they equal that magic number of 180. Same thing happens if I take a pair of same side exterior. They happen to be 70 and 110, which makes the total of 180 again. So you have parallel lines. Same side interiors are going to equal 180 or as supplements. Same with same side exterior. They equal 180 together or their supplements. So Parallel lines cause a lot of special situations. Either angles will be equal to each other or they're going to add up to 180, and that's, you just got to focus on what kind of angles you have so you know which property it is. So looking at some examples, I will ask you to do, I will give you something like this and say, here's one angle measure, the 145, fill in everything else. And that's going to be what you're asked to do. All right, so right away we know these are parallel, like I already talked about. Vertical angles still apply, so 145. I have supplements here. These two add up to 180. So 180 minus 145 is 35. So angle 5 here is 35. And going across diagonally again, this is 35. Right, so now you can use any of those properties you want, or just know that this pattern, corresponding angles are congruent. So 4 on the outside here plops over to angle 1 there. And then this whole pattern repeats itself. We got 35 here, 35 here, and 145 here. You can see if you start at the same angle, that pattern is the same pattern of numbers. Alright, so I will give you at some point next week a thing that says very much like this, 2 parallel lines, a transversal. I might ask you which line is the transversal, and I'm going to ask you, say, hey, here's a number for this angle, fill in all the rest, and it is as straightforward as that. Now, on the back, they get into a little bit more. Of course, we start off with just the angle measures, and now I'm telling you in certain pictures, these lines are parallel. Feel free to draw the pictures in, doesn't matter where the arrows go. Doesn't matter which way they go, they should just be both facing the same direction. Asking you to do some calculations. Well, everything is the same as it was. These, if they're next door to each other, these are supplements. They equal 180. Solve for x, start plugging it in. This would be a good time to pause and solve for x, then click back. 180, 14x equals 98, 98 divided by 14, x will be 7. Plug in. Okay, so 5 times 7, 35 here. Then you start filling them in, 35 here. You can take the corresponding angles up. So this one would be the same as this one, 35 here and 35 here. Even if you fill them all in, you don't need them, that's fine. You just answer the question as you need it. So 9 times 7 plus 82, or do the 180 minus the 135. Either way, it should be 145. Sorry. Okay, 35, 35, 145, 145, 145. Okay, so angle 1, what do we got? 35. Angle 2 was 145. Angle 3 is, yes, the numbers should be very repetitive like that. All right, the last one here. You have these angles, that one and that one. Think about, okay, these angles, they are across the transversal, because I know the lines are parallel this time. They are across the transversal, they're in between the lines, so they are alternate interior. Alternate interior angles are equal to each other. Alright, so sometimes they equal 180, sometimes they're equal. So you have to determine what kind of angles they are. Determine what kind of angles they are. Either set them equal to each other, add them up to 180, and then start solving. So this one, x is 8, plug it in. What do we got here? Now I'm going to plug them into both because 56, 55. I want to make sure my math didn't get messed up here because I know they should be equal. So if I was at 40 plus 15, 55. If I plug them into both, it's like checking my values. I know these should be equal, So I start plugging it through. 45 for my vertical. Oh, sorry, just kidding. 55. 55 here too. All right, so let's see. Angle 1 is 55. Angle 2 and 3, I don't know yet. So I do the 180 minus 55. Now, you don't have to draw all these arrows on here, but I'm just trying to remind you of properties. 125. And probably without marker, it'll probably be a little bit more straightforward. So, all right, let me know if you have questions. Bye.